Alright, so in this video, we're looking at the definition of sine, okay, which is a trig function. And so we first were introduced to the idea of sine in geometry, and we learned it from acute right triangles. So if I had a right triangle, okay, and I had a particular angle, I'll call theta, all right, that particular angle had a sine, and the sine was defined as the opposite side over the hypotenuse. Okay. So if we remember, in a right triangle, the longest side is the hypotenuse. That's the one opposite the 90 degrees. Okay. So I define the sine of theta, which is saying like the sine of this angle, okay, is equal to the opposite side over the hypotenuse. Okay. And so what's interesting about it, it's a ratio. The sine is a relationship from this side to this side when the angle is some particular value. Okay, so it doesn't matter how big or small the length of the sides are. If the angle remains the same, they're going to have a common relationship or ratio. They'll all reduce down to the same thing. So we define sine as that. So if I gave you an example of that, and I had a triangle, okay, and I referred to this as theta, some particular unknown angle, and I told you this side was 7 and this side was 10, okay? Well, I would say the sine of theta, whatever that angle is equal to 7 over 10. They have that relationship. All right? So if I kept that angle the same, whatever that particular angle is, okay, so this is the same theta, okay, but I made these sides longer. Well, if this angle remains the same, they're going to grow proportionately. So I could have something like this. So this is the same unknown angle, right? It's still theta. So if I said its sine in this particular case would be equal to the opposite side over the hypotenuse, which is 14 over 20, and you see that reduces to 7 over 10. So what that means is this angle is going to have the same relationship. Okay, so we can see that in some angles. So let's look back and see if we can find a little bit of a way to prove that with something maybe we're more familiar with. Let's look at another angle. Okay, and we'll look at a 30, 60, 90. Okay, so a 30, 60, 90. So this is a 30, 60, 90. We can refer to this side as A, 2A, and A root 3, right? And this is true for all 30, 60, 90 triangles. So if I gave you an example with a 30, 60, 90 in it, okay, so this is 30 degrees, and I said this side was 2, this side was 4, and this side was 2 root 3, okay? So there's my 30, 60, 90. Well, the sine of 30 degrees is equal to the opposite over the hypotenuse, which is 2 over 4, which we see reduces to 1/2. Okay, so what happens if I make my triangle bigger? Okay, so it's a 30, 60, 90, so I know the relationship of the sides is not going to be is going to stay the same, so that should kind of give us a clue of what's going to happen. Okay, so if I made this side a 10, this side a 20, and this side a 10 root 3, well, in this case, I'd say, well, the sine of 30 degrees is equal to the opposite side over the hypotenuse. Oh, sorry, it should be a 10. And you see that it reduces to 1/2. So it always stays the same. It'll always stay the same. The sine of 30 degrees is always 1/2 because the opposite side and the hypotenuse have this particular relationship where it's 1/2. All right, so that was the first way we learned for a definition of sine, opposite over hypotenuse. Well, in trigonometry, we get introduced the idea of finding sines and cosines for angles that are not acute. So basically, going back to this here, since this particular angle is 90 degrees right here, the sum of these two can only be 90, right? Because the internal sum of a triangle is 180 degrees. So what do we do if we want to find the sine, cosine, tangent, different types of trig functions when they're greater than that? So we have to introduce the idea of sine on a coordinate plane. Okay. So watch what happens if I start throwing triangles onto a coordinate plane. So if I draw something from the origin, okay, which I'm going to refer to as a radius, and then I draw straight down with a 90-degree angle. Okay? So the distance from here to here would be the y value, right? I'm sorry, the x value, whatever that is. And the distance from here to here, because these are perpendicular, is going to be the y value, right? So if I refer to this angle down here as theta, I could say that its sine, if I go back to the definition that I already had, is equal to the opposite side over the hypotenuse. In this case, I'm going to use the coordinate plane and refer to it as the y value over the radius. Okay. And hopefully you can realize that's the same definition, right? The opposite side over the hypotenuse. Well, the reason I'm looking at it from this perspective is I want to deal with angles that are in other quadrants. Okay? And so, for example, here's my second, or before I do, here's my second definition of sine. It can be thought of as the y value over the radius. So if I was to draw another one here, okay, and my radius terminated or stopped over here in my second quadrant, and I drew down my right triangle, okay, and I call this particular angle my theta, well, this is still the y value, but over here, this particular x value, whatever it is, it's going to be negative, right? Because I'm in quadrant 2, my x values are negative, okay, and that's still my positive radius. So in this case, okay, you can see how the lengths of the sides are going to change. Well, this isn't really going to affect my sine because it's just opposite over radius. But if I was to come down over here into quadrant 4, okay, I'd have a positive x value, call this theta now, and I'll call this this is some negative y value over r. So in this case, my sine, right, is going to come out as some negative y value over a positive r. So we can actually start to get negative sines and cosines when we introduce. So let's put some numbers on this and try to make some sense of this. So for example, if I had a particular radius, okay, and I told you the end of that radius was the coordinate point 4, 3. Okay? So what that means is that's where this thing ends. Well, I know if I draw straight down, I would get myself a 90-degree angle. And I go, okay, well, the x value is 4, so from here to here is 4. And from here to here is 3, right? That's how I plot points. I count the x value and I count the y value, right? So I know two sides. Well, if I use Pythagorean theorem, I could figure out that this side is 5. Okay? So if I refer to this inside angle as theta, and I wanted to find the sine value of this particular theta, this angle, I would say the sine of theta is equal to the y value over the r value. So my y distance, you can see it's right there, right, is 3. And through Pythagorean theorem, I figured out that my excuse me, that my radius is 5. So the sine is 3 over 5. Okay? So if I gave you the same thing, but I changed the quadrant, okay? I changed the quadrant, say I did it over here in quadrant 3, okay, and I told you the end of this radius is the coordinate point -3, -4, okay? Well, and then this is my theta. Well, in this case, the x value is still a distance of 3, but it's -3 because it's in the negative direction, and my y value in this case is negative 4, okay? Because I traveled to the left and then down, right? So in this case, my sine value for this particular theta, okay, is going to be equal to, and then if I, the y value over the r, so if I use Pythagorean theorem again, I would get a positive 5. Well, my y value is negative 4, okay, and my r value is 5. So you can see up here in the example above, since my y value was positive, the actual sine value came out positive. But over here, since my y value was negative, my sine value came out negative. Okay? So it's two definitions for sine, opposite over hypotenuse, as well as the y value over the r value when you put it on top of the coordinate plane. And hopefully you see the similarities in them. The applications for this is much more as we move through the course. So this is really something you need to understand, this idea of sine being defined as y over r. And keep in mind the radius is always going to be positive. Okay, the radius is going to be a positive value. And if there's a negative, it's somewhere with these values over here.